It's if you take a two-dimensional element. So along this is the x-axis. What is the x-axis? The fluid element is the x-axis. So y-axis. As it is a two-dimensional x-axis, y-axis. Okay. We change the ink because it will be better to understand here. Here, about the surface, if you are considering it is a dx. Dx is a dy. Now, what are the stresses acting over it? What are the stresses is acting over it? So, over the surface here, normal stress is acting. You write it down. 1. Is it understandable? Tau 1, because if you over this area, if you draw a normal, it is along x-axis and force is also along x-axis. Tau 1. Similarly, here obviously it will be tau 1. Here it will be tau 2. Same case here it will be tau. Okay. Now here, shear stress component is also there. This here opposite. What is that? That is tau. Area is the same area 1 and direction 2. Here also tau. About it, the tau 2, 1. Tau. These are the stresses acting over the two-dimensional fluid element. Now some assumption will put it here. Some assumption. The most important assumption I will see in the fluid dynamics, viscous fluid flow chapter is the body couple is not present here. So no body couple. So here no such body couple is there. No, there is no body couple. Over the element, no body couple is present here. Now, if you consider the moment analysis here, so total moment about the z-axis. What is the z-axis? Z-axis is the perpendicular to the plane. So moment about total moment about the z-axis we are considering here. The total moment about the z-axis will be I. What is I? Is the moment of inertia into the angular acceleration. Moment of inertia is into angular acceleration. The moment of inertia about which axis? That is also z-axis. So what are the total moments? The summation of the total moment is there. T11, T1 and T22, this all normal, don't contribute anything in the case of the moment. They are not contributing anything in the case of the moment. So who is contributing here? Contributing the shear component only. Tau 1, 2. So it's like a couple. You see here 1, tau 1, 1, 2, and tau. This is making one couple. This is making one couple in the anti-clockwise direction. Anti-clockwise we are taking as a positive side. So tau 1, 2 into area. What is the area? area is the temperature. Because this area, z direction is the unit we are taking. Unit. This is the force. This force into this is the couple. Anti-clockwise couple. This is the anti-clockwise couple. Same way, the tau to 1 is causing one clockwise moment. Dx. It's a clockwise. And IZ, this, what is the IZ is the M is the P area, delta X is the volume into 1. That is the mass. Mass into I about the Z is the X square plus Y square. Now the same thing as here, the stress is a state of a point. That means this fluid element will converges into a point. If we take the fluid element and converge this thing into a point, that means the delta X tends to 0 and delta Y or dx, sorry, here is taking the dx. Dx tends to 0 and dx tends to y. That means the total element here converges to a point about the origin. In such a situation, this term will become 0 and we'll getting this thing is the tau 1 is equal to tau. What does it mean? This means that tau ij is equal to tau j. Most important. That means in here, in the previous portion, if you see, in that case, if you write it in the matrix form, tau y, tau 2, t, the t, fraction vector. In the matricular forms, if you're writing in the matrix here, tau 1, 1, tau 2, 1, tau 3, 1, tau 1, 2, tau 2, 2, tau 3, 2, 3, 2, 3. This is a vector quantity. This is also a vector. And this is a second order tensor, stress component. This is a vector. So one second order tensor maps a vector onto a vector. In such a situation, you can see from the previous concept we see the corresponding, the tau 1 2 is equal to tau 2 1. A similar way, all the same. You can write the same way, tau 1 3 is equal to tau 3 1, tau 2 3 is equal to tau. So here, these corresponding terms are equal. These all are equal. So this way we are getting, so in the stress component we are getting this. So this next we will see the concept of the pressure. Next lecture series we will see the concept of the pressure with the continuation of the stress component. The pressure is nothing but the normal stress, but compressive in nature. So whatever you are getting, if the mechanical pressure, one just a prelude to the pressure giving, the mechanical pressure is nothing but, we are writing it the mechanical pressure here.
Mechanical pressure is nothing but the tau 11 plus tau 22 plus tau 3 divided by average of this component, normal components. And why this negative? Because pressure is a compressive in nature. We'll see it next lecture. So after this, next we'll see the concept of the pressure. Then we'll come to the viscosity, bulk modulus, surface tension, and pressure. We'll complete this module with all of these properties discussion.